This is what we're doing today. And working on this handout. This is the first part. We shifted the graph to the right. And we saw that the X-intercept is right here at 2, 0, and the Y-intercept where it hits the blue line, it does not exist. D and E. Okay, so, oops, where that one came from. Okay, so remember, the Y-intercept asks, what is Y when X is 0? Because all along here, X is 0. We need to figure out what Y is. So it's going to be 0, something. So we're going to put in X, 0 for X. Put set X equal to 0. So I'm going to rewrite this. Right, this function is Y equals the cube root of X plus 1 plus, and then on the inside, on the outside is the plus 2. Does anyone see that? The plus 1 is on the inside. On the outside is the plus 2. So first, quick review. On the inside, is this shift my left-right shift or my up-down shift? On the inside.
Left-right.
Left-right. Right, so remember, whenever it's on the inside, right where X is, it's the opposite. So plus, means kind of the opposite of what you think it is. So is this going to be left or right?
Left.
Left, because plus means left. Minus means right when it's on the inside like that. Is everyone on board?
Mm-hmm.
Okay, so this is left 1. And then on the outside, is that my up-down or my left-right? Up-down. So then this is going to be what?
Up 2.
Up 2. Everybody on board? Okay, great. So we're shifting it that way. But now we're going to find it without having to graph it. So here we're going to say, I want to find the y-intercept, make x 0. Because what the y-intercept, says what is y when x is 0. So x is 0, put in 0 for x, and solve for y.
Oh, so we're not graphing this.
Nope, we're not going to graph this
Oh.
one. So we're going to say, all right, y equals cube root of 0 plus 1 plus 2. So 0 plus 1 is what?
1.
1. What's the cube root of 1? Well, multiplied by, so our cube root means what multiplied by itself 3 times gives me what's inside. So what multiplied by itself 3 times gives me 1? 1. So this becomes 1 plus 2.
3.
Yep. Y equals 3. So the point is going to be 0, 3. That's the answer. That's the y-intercept. 0, 0, 3. Now it's finally now we're going to find the x-intercept. How do we do that? We set y equal to 0. Okay, so everybody do that. Rewrite your function. Only instead of y, you're going to put 0. So you're going to rewrite this exactly like it is, only instead of y, you're going to write 0 instead. Everybody do that. So write this function right here. Write it right there, only instead of writing y, you're going to put 0. Right, because y is 0. You know you have some information. You know y is 0. Write the function, only y equal, put in 0 for y. Y is 0. Equals. It's a little bit trickier. It's a lot trickier, actually. 0 equals cube root of x plus 1 plus 2. Now, what do I need to do to solve a radical? I need to solve for x. I need to get the radical symbol all by itself. And that's what we kind of did the warm-up class with the beginning, the first page of this. So how do I get the square root part symbol all by itself? What do I need to get rid of? Yeah, the +2. How do I get rid of +2?
Subtract it away.
Subtract 2. Is everyone on board with that? What's happening to it? 2 is being added to it. How do you undo adding 2?
-2.
Minus 2. Yep, so everybody subtract 2 from both sides. So draw a little, so maybe you want to draw a little line for success down the middle. Boom. Maybe I'll move it over. I'm going to move it over a little bit, give myself a little more room on that side. So I'm going to do -2 from both sides. So I get -2 is equal to cube root of x plus 1. Okay, now we have our radical all by itself. How do we undo the radical?
Square it.
Yeah, almost. So
Or cube it.
cube it,
Cube it.
right. How do you do a cube root? You cube it. How do you undo a square root? You square it. This is a cube root, so we're going to cube it. In other words, we're going to raise everything to the third power. So I'm going to raise this whole side to the third power, this whole side to the third power. So when I do that, does it include the negative symbol? Yes, it's the entire side. So make sure that, like if it was a square root, we would include the negative symbol, the whole thing. All right, so everybody raise -2 to the third power. What do you get? So it should be negative or positive, first of all?
Negative.
Negative. So you do negative times a negative is a positive. So negative. What's 2 to the 8th power?
2 to the third.
Third power, sorry.
8.
8. Sorry, my bad. I was throwing that in there. And then on the other side is just, we undid the cube root part, so it's just x plus 1.
Mhm. And then
Okay.
would you -1 from both sides? now
Yes,
to
you would
split
exactly
that? Okay.
-1 from both sides to get x. I did want to point out something. Oh, typically, so heads up, folks. What I do, which I find easier, is to do the negative separate from the number. So I'll do the negative to the third power, and then I'll do the number to the third power, so I don't get messed up with thinking of it all together, right? Just I do them in parts. Okay. So then we're going to subtract 1 from both sides. And our final answer will be -9 equals x. So it's going to be -9, comma 0. That is our answer.
That's
Everybody-
the y-intercept.
That's the y-intercept. So it says, no, the x-intercept.
That's the x-intercept?
Yeah, x-intercept is, so the x-intercept, y is 0. For the y-intercept, x is 0. The other one is 0, right? So it's kind of, that's how that works. It's kind of, and you can look at it in the graph to kind of remind yourself of, which one's 0 on which axis. How are we doing over here? Okay. So let's take a look at, I feel like we did one of these two maybe. Did we do number 1 here? No, we didn't do any of this?
No, nothing further.
Okay.
No.
All right. So let's do these. I'll do the first one with you, and then I'll have you do the other ones, I think, on your own. So you're going to answer the questions, and you're going to sketch the graph. Not using a graphing calculator. So first, domain and range. Okay, so what's the one thing we can never, ever, ever do in math? Divide by 0. We can never, ever, ever divide by 0. Everybody on board? Good? All right, so we can never, ever divide by 0. That's the first thing. The second thing we can never, ever, ever do in math is take the square root of
Negative number.
a negative number. Square root of positive is fine. Square root of 0 is fine. But it can't be negative. It will not be a real number. It'll be an I. It'll be an imaginary number. Good? And we're only dealing with the real world in this class, real numbers, not imaginary numbers that don't exist. So never take the square root of a negative number. So really, all you folks have to think about in this class in terms of domains. So now we're shifting away from graphs, and we're talking about just about the things you know. If x is in the denominator, then there might be something about when your denominator can't be 0. Do I have, in this function, is there an x on the bottom anywhere? Is there something where you're dividing by x in any way? Or anything with x in it? I'm only getting one nod. Natalia's giving me an answer. Anyone else? In this function up there, are we dividing by x at all? In other words, is it something where I have something with 2 and then something with x on the bottom? Is it like that?
Not at this point.
No. So then I don't have to worry about the first rule, right? I don't have to worry about this one, dividing by 0. That's not a problem. This will never give me a spot where I'm dividing by 0. All right, so then the second question is there a square root or an even root?
No.
No. That's a cube root. You can take a cube root of a negative number. Because what's the cube root of negative 8? What multiplied by itself 3 times gives me negative 8? We just did it. Negative 2. So cube root's fine. That's the S shape. You guys remember that little S shape thing? Cube root can be all real numbers. So here, we're not taking the square root of anything or an even root of anything. So our domain is going to be all real numbers. Negative infinity to positive infinity. So anytime we're dealing with a function, so we're sort of done with determining, like the first exam, I had all of you determine what something's domain and range is from looking at the graph.
Yeah.
Right? And sometimes there are circles or little like weird type, like rectangles or like parallelograms and things like that, right? That's teach you how to use, and dots. That's just you getting used to the idea of domain and ranges. Now we're going to talk about functions. So functions are going to be where you actually have an equation, y equals something with x in it. In this situation now, it's always going to be all real numbers, always, unless, what's the first thing? Unless what? Unless
You divide by 0?
you're dividing by, yeah, unless you have a function with x in it, like the one I just read up earlier, right? Unless you have something where you're dividing by x, or unless what?
Oh, divide by x, not divide by 0.
Divide by x. Because anything you have, okay, so let me explain this. Anytime you have x in the denominator, you have a restriction on what x can be because you can't, you said a second ago,
Oh, divide by 0.
you can't divide by 0. So since I can't divide by 0, x cannot be what?
Not be 0.
Well, no, the denominator cannot be 0. So what would make x 0 up there? If x was what? What plus 1 is 0? Negative 1. So here x cannot be negative 1. Because I divided by 0, the whole world blows up. No good, right? Is everyone on board? So here, x cannot be 0. Oh, sorry, x cannot be negative 1. My bad. Because we can't divide by 0. Everyone on board? Here, if I had the square root of x minus 2, then what? X can't be what? This is a different one. X can't be what? Oh, no, wait, I'm sorry. That's this thing. We have that greater than. We did this last class, right? Does anyone remember that? This is where we do the whole the inside, x minus 2 has to be greater than or equal to 0. Does everyone remember this? It was the domains handout two classes ago, not last class, class before. So we did this on Wednesday. All right, I will pause for a minute. We'll bring that handout up. Right.
Talking about domain of radical functions?
Yep. X plus 3 has to be greater than or equal to 0. Does everyone remember this one? So then what we do, we subtract the 3 from both sides. We said x has to be greater than or equal to negative 3. That was our domain. So when we have a square root, it's one sheet all by itself. It said domain.
It says Unit 4, 10.1, domain of radical functions.
Yep.
Or
It's right here.
10.1, yeah.
So maybe I should put that one in there. This is my reminder. So if it's a square root, you have a restriction. Whatever's inside the square root has to be greater than or equal to 0. Good? We're going to need to use that later on in this handout. However, this one has a 3 right there. So this one, it doesn't matter. This is all real numbers.
Oh, yeah, negative infinity.
Yep, negative infinity to positive infinity. This one here is x is greater than or equal to negative 3. That means here's negative 3, it can equal it, and it can be greater than it. That's my domain. Here, this is my domain. Now, we did this 2 days ago, or 2 classes ago. Now let's get back to our problem. Our problem is this fellow right here. So what's my domain? What's my domain?
Negative infinity, positive infinity.
I would check to the neighbor. Find the domain. Talk to your neighbor. If you're not talking to your neighbor, I'll probably call on you.
Isn't that what we just said?
Mm-hmm.
Domain